Gardinero.
Hi, El Gardinero here, and we will continue our discussion about weathering, and we are now on the chemical forces of weathering. Now, chemical weathering produce clays on which vegetations can grow. So we have two kinds of chemical weathering. The first one is the petrochemical weathering, and then the other one is the geochemical weathering. I'm showing you a profile. As you can see, we have O, A, B, and C horizons, and weathering that takes place on the A and B horizon is what you call the petrochemical weathering, and then the weathering that happens in C horizon is the geochemical weathering. We have different chemical processes of weathering. The first one is hydrolysis, and it concerns about the chemical structure of the soil. And we have the mineral potassium aluminosilicate, and then after hydrolysis you will have your acid silicate and then the potassium hydroxide. So originally, the potassium aluminosilicate is also known as the orthoclase feldspar. After it has hydrolyzed, you will have your acid silicate and potassium hydroxide as a product. And you can further observe that there is a change in the chemical composition of the mineral. And then this is the complete chemical reactions. Again, the acid silicate will be hydrolyzed, and then you will have your kaolinite. Kaolinite is an example of 1:1 type clay. And then silicon dioxide. Acid silicate further hydrolyzes, and then the result is gypsite and silicon dioxide. The next process of chemical weathering is the hydration. You have the ferrous oxide plus water, and you will have your limonite, which is a mineral with yellowish color. Ferrous hydroxide is hematite, and that is reddish in color. The third one is carbonation and other acid processes, or what you call the acidification. Like calcium carbonate, if you apply carbonic acid, you will have this byproduct in soluble bicarbonate. So limestones plus carbonic acid, the product will be soluble bicarbonate. The fourth one is oxidation, which is the removal of one or more electrons from an ion. This is an example of oxidation. Ferrous oxide that is oxidized will become a hematite, that is ferric oxide. And then the fifth one is solution, that is the dissolving of minerals through the solvent action of carbonic acid or hydrogen ions. Like calcium carbonate plus hydrogen, the result will be carbonic acid, and then the calcium ion will be released. Sodium chloride plus HOH, the result will be sodium, chlorine, and water.
Gardinero.